Here we have a limit problem. 2 times k to the power of 1 over n minus 1 to the power of n as n approaches infinity, where k is a positive constant. So to work out this limit, first let's observe what's happening inside the base. So k to the power of 1 over n, it's probably going to approach 1. Let's verify. So if we take the logarithm of k to the power of 1 over n is equal to 1 over n times log k, right? That is equal to log k over n. So as n approaches infinity, obviously we have a constant over infinity, so going to approach 0 for sure. So now that implies, so that means actually, yes, log of, like I said, log of this approach 0. Right? Further, that implies that the inside, because log approaches 0, whatever that's inside has to approach 1, right? The log. So this approach really approaches 1. So actually we have something that's approaching 2 times 1 minus 1, that's 1. 1 to the power of n, so we have something 1 to the power of infinity, undetermined, right? So that reminds me of the definition of E. So limit as n approaches infinity of 1 plus 1 over n to the power of n as n approaches infinity. So indeed we have the base, we have something that's approaching 1. The power approaches infinity, of course. So how can we relate that to this? Right? So maybe first let me just use some shorthand notation. So let an equal to the base, right? 2 times k to the power of 1 over n minus 1, right? Just for convenience. So that means, like I said, k to the power of 1 over n approaches 1. So meaning this approaches 1. So my desired limit 2 to k to the power of 1 over n minus 1 to the power of n is equal to an to the power of n, that is equal to 1 plus an minus 1. Right? Plus 1 minus 1 is the same thing, to the power of n. But notice that I have to make sure that this happens. Right? I have to make sure the power is equal to exactly the reciprocal of this thing. Right? The reciprocal of this thing. Right? So remember, this thing approaches 0, indeed. Right? Minus 1 approaches 1, minus 1 approaches 0. Right? So 1 over an minus 1. Of course, we have to raise to the power of its reciprocal, right? An minus 1 to cancel it out. We still have power of n, so we have n times an minus 1. So notice this time we have the base. The base is approaching e. Right? Keep this in mind. 1 plus an minus 1 to the power of 1 over an minus 1. This time it's approaching e. So all I need is to focus on the power. Right? So n times an minus 1. Right? So again, we have an approaches 1, right? So an minus 1 approaches 0. So we have infinity times 0. Again, so it all comes down to determining which guy approaches faster. Right? So if this guy approaches infinity faster than this guy approaches 0, then probably it's going to turn out to be infinity. But if otherwise, if this guy approaches 0 faster, maybe it's still going to be approaching 0. Maybe they approach at the same speed. Maybe it's going to be constant. But let's find out. So we could use Taylor expansion, of course, but this time I don't think it's necessary. The reason is because when we want to determine the speed of this guy, an minus 1, we have what? We have an minus 1. An is equal to that. So 2 times k to the power of 1 over n minus 1 minus 1 is 2. 2 times k to the power of 1 over n minus 1. Right? We need to determine the speed of this guy approaching 0. At what speed? Right? Could use Taylor expansion, but this time won't be necessary. Because I noticed that I can change the base of this guy. So, first of all, we know for a fact that e to the power of e, x minus 1 over x is approaching 1 as x approaches 0. Right? The reason is because if we differentiate, because remember it's a 0 over 0 type, right? X approaches 0, e to the 0, 1, 1 minus 1, 0, 0 over 0. So we just differentiate, differentiate that, we have e to the x. As x approaches 0, approach 1. Right? And that's why. So again, meaning every time I see this, I can replace it with x. Right? In the process of limit, it's equivalently infinitesimal. Right? So do I have this, right? So e to the power of x. Change the base, like I said. So it's only because k to the power of 1 over n is equal to e to the log of this. Right? So 1 over n log k. All right, type down the power. So in fact, this minus 1 is equal to e to the 1 over n log k minus 1, right? So meaning this is actually equivalent to whatever the power is, right? This is equivalent to the power during the limit process, right? When the power is approaching 0, is it? Yes. So as n approaches infinity, of course. So in order to work out this limit, I just need to replace this with this. Right? I just need to work out the 2 times this. Right? In fact, I want to work out the limit of n times this. Right? So like I said, I need to work out n times this. All right, so n times this stuff, right? 2 times n, then times this. But this is replaced with this already, right? Equivalent during the process. So n cancel out. Eventually, this limit is 2 times log k. Right? So that implies my desired limit, right? So this has to approach 2 times log k. Right? So meaning like I said, the base approaches e. Right? Like I mentioned, approaches e. The power approaches this constant, right? So the whole thing. Right? So the desired limit approaches e to the 2 times log k. Right? But the 2 can be put on the power, right? K to the power of 2. e to the log equal to whatever this is, right? K to the power of 2. Right? Now the question becomes, what if can we generalize the case? Right? Can we replace K with n? What happens? Right? Is it still a constant, or is it approaching n to the power of 2, or whatever?